In this video, we'll discuss dividing monomials. So since we've already talked about monomials in another video, let's get right into it. Let's start talking about exponent laws, and let's just review a couple things that we've seen before. So in the last video, we talked about multiplication, and we talked about taking a power of a power. In this video, let's, for instance, take a look at x to the m over x to the n. If we're doing division, we would subtract the exponents. Now again, in this case, these two numbers, the base has to be the same. That's the only way this works. If the bases aren't the same, I can't just subtract the exponents. It's very similar to the multiplication exponent law, and it makes sense that if in multiplication you add the exponents, division you would subtract the exponents. Okay, another one, anything to the 0 power is always 1. Now a way we can think about that is if I have x to the m over x to the m, well, this would be equal to x to the m minus m, which would be equal to x to the 0 power. And if I think about all the way back here, anything divided by itself is 1. Therefore, anything to the 0 power is 1. And then the last one that we'll review real quick here is if we have a negative exponent. So if we have x to the negative m, that's equal to 1 over x to the positive m. So a way we can think about this as an example, if we have 2 to the negative 3 power, well, that'd be the same as 1 over 2 cubed, which would be 1/8. That's just a quick review of our exponent laws. So now that we've reviewed our exponent laws, let's apply this to an example. So let's say we wanted to simplify this expression that's before us here. So if we're looking at this, I'm going to divide it up into pieces. We're going to look at the numbers themselves. So if I'm looking at just the 2 over 4, that reduces to a half. Cool. And then if I'm looking at just the x's, I can still subtract the exponents. So this becomes x to the 4 minus 3, which becomes just x, technically x over 1, because the 3 here cancel with 3 of them up there. Okay? Likewise, we look at this y piece, and this would be 1 over y. And then likewise, for the z's, we're going to have 1 over z cubed. Okay? And if we smash this all together, what we've got on top is just x, because 1 times x times 1 times 1 is just x. Then we have 2 times 1, which is still 2. Y is y, and z cubed is z cubed. That's one potential answer. Another way you could go with this one is you could do this with negative exponents. Very similar. You'd keep the 1/2, and then you'd have your positive x, or x with a positive exponent, I should say. And then if we look at these two down here, technically they're in the denominator. So we could have y to the negative 1 and z to the negative 3 with multiplication. Either one of these is fine. They both mean the same thing, it's just different ways of writing the same thing. We can write stuff with negative exponents, or we can write them with positive exponents as a fraction. Either way is fine. So let's do one more example. Now let's say we wanted to simplify this expression. This one's a little different because we have this power out here first. So there's 2 ways you can go with this one again. You can either deal with the power by bringing it in to every expression in the parentheses, or you can simplify the inside of the parentheses first. So let's go with that route first. So I'm going to leave the 4 on the outside. So if I think about this, I have an a squared up here and a 7 down here, which means that I'll be left with a to the 5th in the denominator there. Similarly, I've got a 3 and a 4 there. For the b's, 3 minus 4 is negative 1, or I can just think of it, there's a b in the denominator. And then I'm going to distribute this guy in, the 4. So 1 to the 4th power is still 1, but I'll write it here just for the sake of the example. And then we're going to take a to the power of 5 times 4. Remember our power of power law, that still applies. Times b technically to the 1st times also 4. Power of a power still applies. Now if we simplify this a little bit, we'll get 1 over a to the 20th times b to the 4th. And that'd be a simplified expression. The other route you could go is you could distribute the 4 in first. So multiply all of these exponents by 4. So I'm going to have a to the 8th, b to the 12th, a to the 28th, and b to the 16th. And then again, I can just do the subtraction as I would with the exponents. Again, I'll break it up, and then I'll just look at these pieces individually. So we'll look at the a's. Well, I have 8 up top. That's going to cancel 8 of the ones down here. So we'll have a to the 20th in the denominator of the fraction. So we'll have a to the 20th. Or you could write it with a negative exponents. And then you do a very similar thing here. 12 minus 16, that would tell me there's 4 left in the denominator, leaving me just a 1 up top, which is the same thing we got over here. Either way is totally fine. It just depends on whether you'd rather deal with the exponent first or do the subtraction of the exponents first. Just so long as you're careful and you distribute all the way, it doesn't matter what order you do it in.